Okay, we're ready to get going. Okay, so we're gonna talk about code style today. And as you know, that's one of the things that your TA is gonna grade you on for all your milestones. Okay, so why does code style matter? So you write code once, but it's read many times. It's modified many times, often not by the original author. So you're trying to write code, not just code that works, but it's easy to read and to understand. And software projects in the industry live on for a long, long time, actually academia sometimes too. So this is really important. Like if you're a software companies, their key IP is in their software, but it's also true now for many other companies that they have a lot of key IP in software, and that IP is being degraded if the software is not readable. Right? It has to be easy to understand and maintain, as easy as possible to make it to understand and to maintain. Look, code that's hard to read is bug prone because it's hard to reason about. You can't really figure out what it's doing. It's hard to modify because you have to understand a lot of things. And it's challenging to reuse, right? Eventually people go, well, I don't know what this does. I don't know how to change it, so we throw it away. And obviously that's expensive. There's a lot of code. Okay, so we're going to talk about some guiding principles of code style. So first, a few high-level principles, and then a few more specific suggestions. This is a summary of them. But we'll go through each of these so you kind of see all these. You can refer to this back to this at the end. This summary largely mirrors what's on the milestone 1 and other milestone rubrics for code style. So keep those in mind. Okay, so guiding principles. So you're trying to reduce the cognitive load. You're trying to make it easier for a person to understand your code without keeping too many things in his or her mind. So programming requires that you understand a lot of detail. And they've done tests that show that the human working memory is pretty small. Like the number of things that you're keeping right at the front of your memory is about 7, plus or minus 2. So plus or minus 2 is some people keep 9 things in their memory, some people have 5 things in their memory. But it's not a very large number. So if you're trying to minimize how many distinct concepts and specific ideas a person needs to keep in his or her mind as they're reading your code. You also want to explain why. So a person can read your code, and if it's well written, they can understand what it does, but they don't know why it does that. They don't understand the big picture. And you understood when you wrote it, but that person's usually not around, right? When you go to read the code, like they're not sitting by your desk. They might have left the company. They might have left the university. Even if you're the original writer, you actually forget, why did I do it this way? So notes to yourself are very useful. So in this course, in my research, in industry, I read comments that I wrote, and I'd be happy that I wrote that comment, right? Sometimes I'd be sad I didn't write it. Like, I understood this once, why didn't I write myself a better note? So they're even helpful for the original author to come back to. Okay, so really important. Software companies, and any company writes a bunch of software, so hardware companies too, like they pay a lot of attention, if they're at all a decent company, to how good their code style is. So Google, for example, every piece of code that goes back in their code base gets reviewed by 2 other people. One person who's an expert in the system it's in, and one person who's an expert in code style. Sometimes the same person might be, have authorization for both those things. Why do they do that? They're trying to keep the code readable. They want it to be correct, but they also want to make sure someone else can read your code. And most companies that are pretty good do code reviews to make sure people can understand your code, it's written well. So actually, you can do that. So read your code with your teammates, read your teammates' code, give them feedback, and you'll develop a better coding style as a group. But we used to do this actually as we used to force a code review in this course, which was a good experience for students to see how hard it was to read someone else's code, but we just got too busy. So we lightened the workload a little bit, but it is a really good experience to try to read someone else's code, do it in your group. Okay, so let's talk first about what should I be doing in functions? How should I do variables? Should I have a lot of temporary variables or not? So some basic structures. So you want mostly short functions. So Google's coding guide, which is a pretty good one, and I have a link to it at the end of this presentation, says most functions should be 40 lines or less. So shorter is fine, right? So lots of short functions is good. People often write functions that are considerably longer than this, and as soon as you do that, you should think, should I really be doing this? Right? Is there a way to break this up? Why? Because long functions are harder to read. You have to try to keep more things in your head. They're harder to understand. They're harder to maintain. Why are they harder to maintain? Well, there's basically more variables, more to keep in mind if you ever want to change it. It's also harder to reuse, right? This function does a whole lot of stuff. You might want to do 3/4 of what it does somewhere else, but this function does too much stuff. I can't just call it. If my functions are shorter, it's more likely I can call them from more places. Shorter functions, not only do they, they're easier to reuse and you don't have to keep track of so many variables, they essentially name pieces of functionality. If you give your functions good names, you can see, oh, it's this block of code, what might have been 20 lines of code in some bigger functions, you've now given it a name, so I can see what does it do, and I may not even have to read that 20 lines. Just the function name tells me what it did, and I can understand the higher level structure. One of the ways that functions get too long is that often people didn't start out thinking I'll make a really long function, but they basically keep adding to it. So they just need to add a few more cases, they need a few more lines. And if that happens many times over time, the function gets too big. So this is common. So that's why you have to do something called refactoring. So refactoring just means rewriting. Code's getting messy. This function's getting too long. I should go in, I should split it up into smaller, an overall control routine and some helper routines. And I'm going to run my tests a lot as I do that refactoring. I'm going to do a little refactoring, run my tests, because if I break something, I want to know it's the last thing I did, not something I did today, right? I decided I would just rewrite all sorts of code, and now at the end of the day, nothing works, and I feel really bad. Variables. So you want good variable names. They should describe what's in this variable, what's its purpose. The idea is that that name gives you enough information that you often don't have to actually go look at how was it initialized. You can just from the name infer a lot. And temporaries are a bit of a balance. So I guess first, try to keep a smaller number of variables in scope. I'll show you what that means. If you basically declare your variables close to where they're used, they're not alive as long. And that actually helps reduce cognitive load. I don't have to keep track of so many variables because there just aren't as many variables. The functions are short, and I declare my variables exactly when I need them and no earlier. There aren't as many variables to keep track of, right? So that's a good thing to do. Temporary variables are kind of a plus minus. So you can have too many temporary variables. They can make your code hard to read because you're kind of renaming your variables all the time. On the other hand, if you try to do too much on one line with no temporaries, sometimes that line of code can become also very hard to read because you're kind of not naming any of the intermediate parts. So I would say that it's kind of like writing style, right? Like there's no absolute of you should write always short sentences or always long sentences. Sometimes one works better than the other. Okay, naming conventions. So you want to make your variable names descriptive. That means often there are multiple words. The two typical ways people do that is they use what's called snake case. Snake case is use underscore to separate words, or use camel case, which basically means you capitalize every new word. It doesn't really matter. Both of these are widely used. If you want your code to look beautiful, you as a team could decide we'll always use one or we'll always use the other. I don't care all that much, right? So also if like you guys, different people use different conventions in different functions, it's not the end of the world. Your TA might say, hey, it'd be look nicer if you did this, but it's not a big deal. And we don't really care between these. We do care if you basically go, I'm never going to use names longer than a word. That probably means that your variable names are too short. It's nice to be able to tell what's a constant versus what's a variable very quickly. There are two common conventions. One is put the letter K at the start to mean constant, or put the whole thing in capitals. Either of those is a pretty reasonable convention. And then I'm going to make one small change to my slides here. Yeah, I guess I won't do it. Yes, I will do this. I can't help myself. I probably should have used a lowercase letter there. By convention, you normally start type names with a capital, and then it's just easy to tell that this is a type. So I'm defining a class. I'm going to call it street database with a capital S. So I can. Sorry to interrupt. There's the one with the OCCS improvements room. Okay, I got to do that. Okay. Yeah, showing the whole screen instead of that. So I got to remember to do that. Thank you. You're welcome. Let's see if I hide these controls again. Okay, so I can immediately tell in my code now that this is the name of a type because I started it with a capital S, and I'm not doing that for variables. Here's a variable I started with a lowercase letter. So pretty common convention, it's kind of convenient. Okay, so here's part of the code for a function you actually have to write in milestone 1. And so it's find street segment length, and it's kind of multiple cases. So there's a case where there's no curve points, there's a case where there are curve points. Written this function already, have you guys written this function yet? Yeah. Okay, so you know the two cases. I'm only showing the code for one case with an else clause. We eventually determine what is the right for this thing. We don't have functionality here very much. What do you think about how the code works? So if you've written this, you know exactly, you know what this is doing. How do you like this code? Is this nice, easy to read code? Anything you do to improve it. Okay? If you can't think of anything you do to improve it, then you go like, TA is going to be ecstatic with this code. It's like the best ever, right? So, what do you think? Yeah, so it does have comments, and you're right, we should have comments in here saying, what do we do? Anything else? Like just the structure, the variable names, that kind of thing. So we're kind of looking at like low level, how did the person do this? The functionality of this piece is fine. There are no bugs in what I've shown here. But is it as clear as it could be? Okay, so you would base, so you're saying you would do right, so you don't like the variable names? You don't like the variable names, is that right? So you don't like int1, you don't like this, like you're not the best variable names. Is that right? Yeah. I agree with you. These aren't the worst names, right? But we didn't kind of go crazy and say I, J, X, but they're not the best either. Anything else? So the names could be better, should be commented. Okay, so you get. I'm going to gradually start reformatting this. We'll see how it looks. And let me see, this is a bit loud. I don't know if I can actually turn this off now. Move this over there. Okay, so the first thing is the person has properly indented, which is good. It's a very basic thing. They didn't use any vertical white space. It's actually easier to read with vertical white space. It basically behaves like paragraphs when you're writing let's see if I can get rid of this for a second and turn down the volume. Okay, is that better? I think I got rid of a bunch of echo. Let me click on that now to go back to full screen. So yeah, lack of vertical white space can make this harder to read. So what do I mean by that? If I break it up with some lines, some blank lines, well, I think this is easier to read. Because I can kind of see, okay, there's creating some variables, getting the street segment info, or the ID that was passed in, and then I check the curve points, I get the intersections, I convert from lat long, I find the length. I would say it's a bit easier to read. What do you guys think? Now you could do this too much. You don't want to put, I mean, this is arguably like quite a bit, but we're just highlighting the concept. So maybe go, maybe it's a few too many blank lines. Maybe I wouldn't put all of those in, because if you put a blank line after every line, that's not useful. Another problem this code has is it's not limiting the scope of the variables. So it's got a lot of function scope variables. So it's declaring the variables at the start of the function, and it doesn't need to declare them so early. So if I look at these variables, length, for example, is declared way up here, set to 0, and then it's not used till we get down to here. So I've increased the cognitive load a bit. Why did I declare this variable so early when I don't need it? Sometimes this is like an old habit. Early versions of C, you had to do this, okay? But you don't have to do it anymore. Any modern version of C or C++, you can declare a variable basically close to where you use it. And some of these variables are only used they're not even used in both the if and the else. So these distance variables were actually never used in this yellow code block. So if I'm reading the if part of the code, I don't actually even need to be thinking about those. They would be used down here. The code that I haven't shown you. but it's better to declare them just where they're used then. Okay, so if I declare them in the smallest scope where I can, so remember every time I open one of these brackets, I'm basically making a new scope, right? And your variable is alive from where you declare it to the end of the scope, closing brackets. So I can make my variables more local, like have a smaller lifetime. Okay, so how do I do that? Well, I just did it. Okay, so a bunch of these, right? We had these dist first, dist last, etc. variables, and they're going to be down here. Okay, I don't even need to look at those anymore when I'm looking at the if clause. Length, I can, instead of setting it equal to 0, declaring it, I declared it set equal to 0, I can just declare it right here, right when I set it a value. It's cleaner, right? It's one less line of code. This is where I need it, I declare it, I immediately initialize it. I initialize it to a proper value, not to just 0 as a placeholder, because there's no real reason I was initializing that to 0. Does this make sense? You guys agree this looks better? All right. The variable names are not the best. Okay, so again, they're not the worst, but I have variable names like int1, int2, lat1, lat2. Okay, why are those not the best names? Well, we used to have some information about which was the from and which was the to point on this street segment. And when we start getting the distances to curve points, we actually have to keep track of who's the from and who's the to, right? What's the start and what's the end? And we had that, but then we kind of lost it in our naming convention. We turned it to 1 and 2. Now, if I trace back through the code, I can see that 1 came from, 2 came from 2. But I probably should just use a name that makes that clear. It's not clear why I just decided to number them 1 and 2. Okay, I also have a temporary variable here, so length. When I create this variable length, the only thing I ever do with it is return it. So it's not terrible, but why did I bother creating this temporary variable that's only used once? So we can improve our variable names here, and we can. I would argue that this temporary does not improve readability. I say that actually makes it a little bit worse because it actually makes my code a little bit longer and only use it once. So why bother creating a variable for that? Okay, so let's see what it would look like if we change. Well, here's another one. Okay, another poor name is maybe the worst one here. ID. Okay, so we used our type def, we said it's a street segment index, and it's saying that it's an ID. The worst name, but if I have a longer code here, I may wind up with various kinds of IDs, like intersection IDs, right? So having one variable called ID is probably not a long enough name. We have a lot of different IDs. So I'm going to call that street seg ID. So I know that's a street segment as I read the code. We have this info variable. Okay, info is not a very good name. So I can use a slightly better name by saying it's seg info. So at least I know, well, it's from a street segment. This name suggests what is the info for. And I just got, okay, so basically said these inter1 and inter2 were not the best names. We lost information about this in the from point to the to point. We're also not doing much with them, right? We just basically looked up the from and the to in our seg info and gave them new names. It's not a lot of work that we're doing, and we're creating a new variable. So we can just get rid of those temporaries. Right? I can just directly send seg info.from and seg info.to into this get intersection position to get the lat longs. So which of these do you like better? Right? This one had some extra temporaries. This one has fewer temporaries, and it's 2 lines shorter because of that. So which one do you like? Do you like the with temporaries or without? What do you think? Yeah. Without. Okay, so I like it better without too. I don't think temporaries helped me here. Okay, I could rename these variables. I had like lat long 1 and lat long 2. I could rename those to say they're both from and to. Now, arguably, this is not a better name because it doesn't say it's a lat long. So the other one told me it was lat long, but didn't tell me it was from or to. So maybe a better name still would be tell a person all of that, right? Maybe I should call this, lat long or LL from. That might be a better, because Why did I choose the word false? Maybe that's not the best. So try to make your names as descriptive as possible. But notice also that these are again temporaries. I don't use them much. I could just paste this function in here and get rid of the temporary. So I can try that, see what it looks like. And let's see. Which is what I'm going to do there. Okay, so if I paste it in, whoops, let's go back here. Okay, so I could just paste this whole thing in, and then I get this. I get seginfo.from, get its position, and pass that and the same thing for the two position and find this is between 2 points, and just return that. So basically shorten this down to 1 line. So do you like this better or worse than the previous one? Yeah, I actually personally find this worse too. I don't like doing too much on 1 line. So to my mind, it's actually interesting. One of my tutorial TAs, not this year, but another year, strong people believe this was better. So he liked it. That's the other TAs. People are kind of split. But most think this is a bit too hard to read. Right? You start doing too many things on 1 line and sort of read it from the inside out. Okay, I did this, and then I called this, but then you start to kind of have a cognitive load issue again, like trying to figure out this 1 line without anything. Essentially, these Latin longs and so on are not named anymore. So now without some temporaries, I have to kind of figure out what this whole thing means all in 1 shot. So I find that harder. So I personally find the previous one better. This to me is eliminating too many temporaries. The other reason I like to have some temporaries is when I use a debugger, it's more convenient. So if I debug this code and I say step over, I go over a lot of stuff. A lot of function calls in here and so on. And I could step into these, trying to see like what's going on, but now maybe I'm kind of going through the details a lot. With some temporaries, I can basically in the debugger easily see what are these things, right? So I kind of like to go for a middle ground. I don't like hate all temporaries, but I don't want to have a million of them either. And yeah, so I would probably stop with this one, but some people would go all the way to this. Okay, so this is what the code looked like before. It didn't look terrible. You know, it's not like we did a cartoon of bad code. But the new code, I think, does look significantly better. It's actually shorter, and the variable names are better, and it's easier to see the high-level structure because of the variable spacing. So you have like a relatively small piece of code like this low-level structure does make it easier to read. Okay, so that's low-level structure. Let's talk about commenting. Okay, so first, you probably don't comment enough. Usually people don't. When I was at Altera, we'd actually just use scripts to go look at how many comments a file had, and if less than 25% of the lines were comments, it's usually we actually schedule it for a code, right? It's probably going to be hard to read. It actually works pretty well. And more than 25% was good. But less than 25% is usually hard to read, and the author usually didn't think. There's a couple things. Just thought it was all obvious, right? Didn't write enough comments because the person wasn't thinking enough about how hard it could be, so else to figure it out. Or thought I'll get back to it later, right? I'll come back at some point in the future and write all the comments. Don't do that. Write the comments as you're doing it. I mean, as you're debugging a routine, you're like, maybe we'll delete this routine. Okay, maybe you don't have to write it right then, but get that routine, use it working, you're going to check it in, write comments. Okay, so there are different kinds of comments. So in this course, we've given you comments that are at the level of a file or an API. Okay, so they're actually API level comments, describing like an interface that you can use a whole bunch of functions together. And they're in a header file. So the whole header file has comments describing an API. We also have comments, and this particular one is essentially at the top of the file. It's giving an overview of what goes in this file, and in this case, what is the API that this whole file is going to be. Okay, this is actually the Loop3 database one. We also have comments above every single function. We put those comments in the declaration, right? The header file. If we want people to be able to see those comments when they're going to go use the function. They shouldn't go have to see how the function is written to see how to use it. So write those comments too. We have comments on the structures and classes that we've defined, so basically new data types. So these are the actual comments for street segment. There is a data type called street segment info. So it's a struct, basically the same thing as a class. And we have a comment saying, what is this for? What's the concept that this class is representing? And then we have comments on every single data member. Okay, what exactly is this data member doing? We don't have any function members in this, but if we did, we'd have comments on those too. And then we have some comments. We haven't shown you this, but in general, you'll have comments on just blocks of code, right? Like, so what is this block of code doing for the next 12 lines or next 2 lines? Okay, so all those comments occur in code. I've given you 4 kinds of comments. Which do you think are most important? Because you guys are good sports for showing up before a test. No matter what you answer, if you answer anything, we need to be a chocolate. And this is not one of those ones where there's a completely right or wrong answer. I have my opinion. Sometimes other people have different opinions. So commenting is good. So this is not like whatever one I say is most important, write that and don't ever write the other ones. But I think there are some kinds of comments that are more important than others. So what do you think? What do you think is least important? Maybe that's easier. I showed you 4 types, right? So block of code, structure or class that you've declared, at the API level or entire file level, and the function level, right? Like, what is this function? So which of those 4 do you think is probably the least important? What do you think? Yeah, so I'd agree with you. The code block is the least important. And the reason it's the least important is it's the furthest from the big picture. So the block of code can be helpful, definitely, to comment the block of code. But if you didn't comment it, as long as the code's not terrible, the person can read it and figure out what's going on. Maybe it's just a little bit slower. Maybe there's a little bit of trickiness that the person wouldn't get. It's generally harder to figure out, why do I have this data structure, right? These comments on data structures and classes are quite important, because generally you can figure a program out if you can figure out its data. If you can't figure its data out, it's quite hard to figure out. You have to read all sorts of code that's using this data structure, try to figure out what is this for. Are there rules, are there conventions on it? That's quite hard. So you want to heavily comment when you make a new data structure. So that one's also quite important. What do you think about these 2? Do you think function comments are important? Yeah, function is important too. Okay, so I say function is an important one, because it makes you much more productive in code, right? What do I do with this function? So it's an important one, although I would argue that others may disagree that the overall comment on a whole API, what is this about? What is this whole file doing on any major conventions, is even more important. Because again, difficult to figure out just by reading. I've got 20 functions in the file and tell me what each one does. You still not know, what is the purpose of this whole file, right? Should I even read any further? Like, let's say vector have no comments, right? There's just vector, it's silent on what am I, but then every member function is commented. So if you read what do the member functions do, maybe you can figure out what a vector is. You probably don't want to do that. You probably want to know what is a vector, because I could comment on the class, or sometimes we have a bunch of functions that we put together like this on the file. And then you do want to know what every single member means. So you really should do both. People often neglect these big picture comments because it's just implicit in their mind. They don't think to write it. So try to write a big picture. And this might be shorter. In your code, it might be what kinds of things should go in this file. That's actually useful for people in the future, so they don't put stuff in some file or some class that doesn't belong there. It's like, what is the purpose of this file or class? Does that make sense? Okay. So, yeah, so 2 principles here. First, your documentation should be in the comments. If you go write a separate document that describes how does your code work, you can have like a high-level README and architecture description. Those can be useful, but they have to be quite high level, and you only really want like one of them, right? Or maybe a couple. It's usually like a README or something. It's a very big picture of the program. The problem with other documentation is it usually gets out of date. Right? If you keep your documentation in the comments, then when the person updates the code, he or she will hopefully update the comments. There's often some other document somewhere, the odds of it getting updated are very low. So again, except for maybe a very big picture comment that just says, this whole project is about this. Okay, and the most important comments in the set, they give the big picture, because that's the hardest thing for somebody to infer by reading lots of code, right? Why did you do this? What are your key design choices here? So my hierarchy is basically, well, I want all of these things, but I want sort of the tops of files, big picture, the most important, class and data structure, also very important. Tell me how this data works. Tell me the whole class, then tell me every data member. Declarations of functions, that should be in the header file, so I can see it. Your IDE will even show you those comments now. If you put them right above the header file declaration, then your IDE, it will actually start typing that name and shows you the comment, so it's very helpful. That's why it's in the .h file, not in the definition of the .cpp. And any tricky code, right? So that's like a block of code that's just kind of hard to understand. You can describe that, it's helpful. You should think about if this code's really tricky, is there a way to rewrite it simpler? But sometimes you just have to. You don't want to leave commented out code in your project. So you've written some code, it doesn't quite work, you decide to do it another way, but then you leave it commented out. You shouldn't do that. You're going to leave it commented out for a little while. You know, you're still thinking about it, you're working on it. But once you've decided I'm not using this code, you should delete it. If you ever need to get it back, it's in Git. And you don't want everybody reading this file for the next let's go several weeks, in this maybe several years, reading this commented out code that just doesn't do anything, right? Get rid of it. You don't want to translate clear code to English. So you don't write a loop that says, you know, for I equals 0 to I equals n, and you write a comment above it saying loop from 0 to n. Like, that is useless, and a person cannot read the programming language that he or she is working in. Right? There's no possible way you can write a comment that will help that person. So those comments are just kind of a distraction. They could get out of date if somebody changes their code. Okay, so I would argue that it's basically big picture is the most important, and the low-level details are still useful but less important. Okay, duplicate code. So you want to avoid duplicated code. Why? Because it can probably be extracted into its own function, makes your code shorter. You just call it from multiple places. Also, it was likely when you have duplicate code, what usually happens is people write the code once and they copy it, right? They paste it in, they change some of the variable names. And they often make a mistake, right? They forget to change certain variables. So it's a common source of bugs. Okay, so here's code for another function for milestone number 1. And let's see what it's doing. Let's see. This is, so we're trying to load up all the street segments that are connected to a certain intersection. Okay? So we talked about this one repeatedly, right? It's like a bigger function to show. So what does it do? So we've got a loop. We're going through all the street segments. For a street segment, we're getting the info on it. And then we're basically saying, we're seeing, is this street segment already in the list for some intersection, right? So it's from intersection, is it already in that list? Or that vector? If it isn't in there, we put it in. Okay, this is like an alternative way to load intersection street segments. We did it kind of a different code before. We looped over all the intersections. Here it's looping over all the street segments, because you can do it this way too. And we look at the two end, right? Each street segment has 2 intersections, so we do basically the same thing, right? Let's check if it's in the vector already for that intersection, 2 intersection. If it isn't, we'll put it in. Okay, so before in this tutorial, we went through all the intersections, asking what are the street segments. Here we're going through all the street segments, asking what are the intersections, and we're using the loading intersection street segments data structure. It's kind of the opposite way. And because of that, we have to kind of do this extra checking that I already put in. Because every street segment is actually, we have 2 different intersections associated with this street segment. So I want to check. I don't put it in there already. Okay, so look at this code. What do you think of this code? Can you make it clear? So standard find is an algorithm, but a templated function inside of STL. And it basically is just saying from the beginning of the container, like this vector for that from the intersection, to its end, so the whole thing, see if the street segment ID is in there, okay? And it's going to turn Boolean. And if, gosh, it's going to turn the iterator, sorry. If that iterator is equal to the end iterator, it means it wasn't in there, so we do a pushback. All right, so that's what this code is doing. And then we basically do the same check for the two intersections. So we're avoiding duplicates right away. Just checking this on there, and we're checking both intersections. So do you think this code can be improved? What would you do?
I think it uses the intersections using SS
Yeah, so you could put them into two variables. We could make it temporary. I think that'd be better. Okay, so we could make temporaries. Everything else you notice in this. Look at this block of code. Look at this comment and these lines. Then look at this comment and these lines. Do they look similar? Yeah, so when you see code like that, that looks that similar, like what is the difference between this code? Actually, which columns are there? So what's the difference? Yeah, one is from and one is to. So if I see code that looks the same, but I change one of the variables, what can I do? You can make a helper function, right? That's crying out for a helper function. You basically say, well, these lines of code are doing the same thing with a different variable. If I just pass that variable into a function that did that, I wouldn't have to write this code twice. Okay? So, and that would probably also be easier to read. I told you what this code does, but this is calling find, it's getting the iterator, it's checking if the iterator is the end, which is telling us, well, the comment tells us this, right? We're checking this duplicate, and otherwise we put it in. But if we give this, what is the function? We give the function a name, right? It's probably going to be a little easier. But being a function will tell us probably what it does, rather than having a comment that tells us what the block code does. One other thing, so this is hard to notice, but basically, yeah, this code's identical, except we've changed the from intersection to the to intersection, to, except that one. That one's still from. Should it be from? Does that make sense? Okay, so if you think about it, this one actually doesn't make sense. I just checked if the to intersection, and I already have the street segment in the to intersection, and if I don't, I should put it in the to intersection vector, but I didn't put it from the intersection vector. Why? This is a common mistake. I copied this block of code, and then I started changing variables, and I forgot to change it. And it's actually very hard to see now, right? If you probably work with the debugger, you would know this state is going on with this variable. But then your eye starts filling it in to see the pattern, and you'll notice that one of these variables is wrong. So this isn't great, okay? So it's duplicate code. It actually has a bug in it. It's hard to see. So if I make that into a helper function, I'll give it a name, insert delete, and all it needs to do is I give it the vector, right? So the vector associated, this is the vector, right? So I'll take from the from intersection, give me the vector of street segments, and then I want to pass in street segment I'm considering, insert it if it's not a duplicate, okay? And I call that same function twice. This is a lot easier to read. And I haven't shown you the function. The function is going to be not too hard to read. It's just a few lines of code I showed you before, and show a column above saying what it does. You guys agree? It's better? Anything else you would change in this? What do you think of these comments? Good comment, bad comment. So in my opinion, this comment's not, I mean, most comments are still somewhat helpful. Don't look at me wrong and start deleting comments. But this comment is relatively redundant today, okay? And the two comments are basically the same. So it's not the worst, but if I kind of reorganize this a little bit, I could want to make higher level comments. So why am I telling you I'm doing this and then I'm doing this? Could I just say, I need to do this for both ends of the street segments? So it's a bit wordy, it's a bit repetitive. And it doesn't really say why. right? So, and I now made sort of more of a paragraph. This is what looks more like a blog quote. So add the street segments on duplicate, and see I did it twice for the from and to. Probably I should say that. You know, I should probably give a little more information about why do I think there could be a duplicate, right? But someone said that, you know, will there be duplicates? Am I just being conservative? So maybe I should give a little more why, but I haven't done that. This is better though, because I've commented at a little bit higher level, right? Okay, that's it for that part of like code style. All good? Okay, so I'm gonna do a quick demo of how you can refactor code. So the state of code is that it usually, entropy gradually increases in code as you write it and change things and fix bugs. So you have to periodically go back and go, this code's getting messy, I need to refactor it. Refactoring is just like revising, right? I want to keep it working, but I want to make it look better. Hey, sorry, you have a question? Yeah, auto format's fine. Well, I'm going to show you how to auto format code right now. Basically, every IDE can do auto format. There's like a million ways to auto format code. So you don't have to go, I've never used Google auto format. You can just use it in your IDE. The large projects I have, we have scripts essentially just go through and format or code base on that. So you guys can do this. But that's just so we make sure we have a consistent format for code bases called 1,000 lines. You guys can use auto format the IPE if you want your vertical spacing and stuff. If you don't like your horizontal spacing, you can auto format as well. You can then change it. You know, like if you don't want more white space, it's a vertical white space, you put that in there. Does that make sense? The horizontal format is very trivial. So auto format and lines all your brackets up, you can sort of that. Does that make sense? If you like doing it by hand, you like putting the spaces in, feel free. It's kind of relaxing, but you don't have to. Okay, so let me show you a quick demo on this, and then we'll take a break. Let's see. Why do you guys not see my screen right now? Oh, I see. There must be something strange going on here. Okay. Let's see if I can make this. Okay, hopefully now you can see my screen properly. Okay, can you see that okay? Okay, I have here my favorite M1 function. Let's see if I can make this smaller so you can see it. Okay, so my favorite M1 function is just my m1.cpp, and you saw this last week, and I've only written one function that works so far. So it is my find street segments of intersection. Okay, and actually, yeah. So I put the comment here after it, but it. Yeah, so it's basically if I hover over it, it's actually showing the comment that's in the header file. Okay, so why you want is very helpful. Right? It's another reason to put the comments of what a function does in the header file. of the function. And then you put comments, if you want to, about how the function works in the .cpp file. Now, that's not as important as the header file, but it can be useful. So here we've got a comment saying it's going to be fast because we're just returning something from a global variable. And all the real work is done in load map. So here's load map, and load map loads our low-level data, and then it's doing the code that we saw last week, where it's going through all the intersections. Here, make this a little bit bigger. You guys see this okay or not? Let me, I'll still make it 1 unit bigger. And okay, so it's going through all the intersections, it's finding all the street segments that are connected to them, and it's storing them in this two-dimensional map. So you know this code super well, okay? What do you think of this code? I've now shown you many versions of it, just for readability. There are no bugs in this. Okay, so if I run this, I can do that right now. So I go here to my Makefile tools. Maybe I have to zoom out one because I think now I can't actually see my Makefile tools. So let's do that. Okay, so I'm just gonna, I've got it set up to build the unit test debug build. I'm gonna build it. Okay, so it built. I can run ece297 exercise 1. Okay, it's going to start running. I only expect one function to pass, but it should pass. And let's see. So we're want to go way back to the start of this. Oh, actually, Control C that. Let's do this into more so I can actually see it better. Okay, so I'm running a bunch of tests, and basically my first error is directly connected. Okay, so I know that looking at this before, there's the other test suite from first, there's no error from it. I'm going to get a bunch of errors from the two functions in this test suite I haven't written yet, so a bunch of errors for those. And then it basically says 2 out of 3 tests failed. Okay, well, that's good, because I only wrote one function, so it works. So this function is working, but let's look at the, let me get rid of this terminal. Like, what do you think of this code? TA will not like this code, okay? This is like a style ball. So what's bad about this? Do you think anything is bad here? And it's all load map that I'm not happy with. This other function, that's one line of code, it's got a comment. That's pretty good, right? And we use a pretty good name, pretty long description name for a global variable. This function finds two things intersection was pretty good. The load map is going to make it to the stack. So what should you do to make your TA happier?
Change the name.
So which name? What name do you not like? So you don't like num? Yeah, num's kind of a bad name. What do you think is num? Intersection street, yeah, so num is get num intersections. So I call get num intersections and so not a great variable name. And you think, well, no one will do that. Trust me, people will do that. Okay, so I can go through it. I could just change this by hand, but I can also highlight it, right click, and I can say rename symbol. Okay, so right now it's num. What do you think we should call it? Let's call it num intersections. Okay, sound good? All right, I'm going to use camel case, first letter lowercase because it's a variable, next word. Okay, and basically it found all the nums and changed them to num intersections. And the rename is smart. If I actually use num somewhere else as part of a different variable or outside the scope of this function, it won't change it. So it's like a smart changer. It does exactly what you hope. Find this variable, change it to this. Okay, and it knows what that variable is. Any other names in here that you'd like to change? Yeah, I is terrible. Okay, like this is awful. Especially because it's not, I mean, if it was a really, really simple counter, you know, that you couldn't figure out a good name for, fine, but it's going over all the intersections. So I is a pretty bad name. So what do you want to, so I'm going to click, right click, rename symbol. What do you want to call it? Yeah, so let's call it intersection ID. So I'll do that. Okay, and now I is a pretty small word, right? So if I just did global search and replace all I's to this, I'm gonna get like this I and all sorts of I's. See all these highlighted I's? So hopefully it doesn't happen. And it doesn't. You see that it actually, I didn't change every I in the document to intersection ID or the code. It was smarter. It just changed the variable I that was declared there, all the uses of it, which are all inside this loop. It's just declared the loop and change it to intersection ID. Okay? So looks good. Any other variables we should rename? Maybe, what do you think of X? Get num intersection street segment. Well, X is not a good name for this. Okay? What do you think is a better name? Lots of names better than X. First, I have to start integers with like I or N. So give me an integer. Or put an ID on the end, something like that. What is this? I'm basically saying, what is intersection in a map? Give me the number of intersections, or number of street segments, right? That's what this function is doing. So what would be a better name for X? Yeah, it could be num street segments. If I want to be a little shorter, maybe I'll say, this is a pretty local variable, so maybe I'll say, maybe I'll use a shorthand. Maybe I'll say numsegs, right? Or I can say numsegs at intersection, or numsegs at inter. Like all of those are pretty good. What do you want? Numsegs at inter. What do you like? You like it at inter? Okay. Okay, so numsegs at inter, so I do that. And it's changed. And if I change my mind, well, you guys know this. You can hit Control Z to undo something, right? Control Y to redo it, so I can go back and forth, look at the code. Any other variables? Like, I see one more one pretty bad. Yeah, change my guy, right? And you'd be surprised. We will definitely get code that looks like this, right? And I wrote, early in my career, I wrote electromagnetic simulation software, and so it's hardcore electrical engineering, and people in that domain tended to write code with lots of short variable names. It's really hard to read. Okay, so let's change J. What would be a better name for this? What is it looping over? Yeah, so it's looping over. So yeah, so we can call it the seg index, street seg SS index. Seg index looks fine, right? Seg IDX, so that sounds good. Seg index. All right, so we changed that, and all looks good. I probably should be careful that, like, maybe we use these, like this index and this ID are kind of close. So it's probably good that I'm using ID to mean the major ID for this, and index is just a small counter. Like your code is trying to use the same convention. Okay, so that looks a lot better. So we just changed all the names. I told you when you refactor, you should build often. So I'm going to rebuild this. Okay, so I just built it, and I can run exercise again. I can also copy over the test if I want and run one, but this is pretty convenient. I'm just going to run exercise. And it basically, the first failure is not in the function I've written. Okay, it's in the functions I haven't written. If I page down a little bit, I'm going to see that I pass 2 out of 3 tests, which is as good as it gets because that's all I've written. Okay, so I passed 2 out of 3 tests. So I'm basically, as you're refactoring, make sure you don't have what's called a regression. You basically break some things that used to work. So you want to test often. Right? All I did was rename variables. I want to test right now. So if I made a mistake, it won't be very hard for me to find now. I just keep working for 3 more hours of this mistake. It'll be hard for me to find. Okay, so this looks better. Anything else I should do? Yeah, it's kind of nasty. I didn't put spaces around my operators and so on. I don't really like that. Also, it's kind of bizarre, right? Like I put the code that goes with this if statement on the same line. That's pretty nasty. This is hard to read. So I have indented the for loop, but I didn't put spaces around my operators. Didn't kind of inexplicably in if statements, just decided to put like what I do on the same line. So I could go through and just reformat this by hand, but basically every IDE also has the ability to do that automatically. So I can select what I want, right click and say format selection. Okay, and it looks a lot nicer, right? Now, I personally, just to keep code shorter, I like to put that bracket on the same line. So I'm going to go through and kind of rework it a little bit, because that's, but still, so the reformat helped a lot, right? And if I wasn't so picky, I could have just left it, but I like that personal change, so I was going to tweak it a little. Okay, I'm paranoid, so I'm going to immediately rebuild. Okay, it built, that's great. And then I'm going to run ece297 exercise again. Oops, it's probably still running, so let's control C it. Okay, I'm going to run ece297 exercise again, and definitely should work, and it did. Okay, if I page through a few of these, you'll see 2 out of 3 tests pass again. So 2 out of 3 tests pass. So it's a little bit paranoid, but that's how I recommend you do things when you're refactoring. You build, you test often. Testing is cheap compared to your time. Let's see. Okay, there's another thing you can do in Visual Studio. The things that I showed you are all pretty standard. Every IDE can do them. Visual Studio has an interesting, slightly unusual thing that it can do. So I can basically highlight some text. So let's say I highlight num6. So it's not even an entire variable, it's just part of a variable. And I can hit Control D, and Control D is going to go find all the uses of num6. Okay, so here it found 2. Let's find something that has even more. Let's find intersection. Okay, so it's lots of intersections. I just went off and I found all sorts of intersections. Every time I hit Control D, it highlights another one. Okay, I can just keep going. Now, if I want to, I've now basically multi-selected all these things, and I can keep selecting more and more of them if I want. And I can basically say, let's change that. Let's not call it intersection, let's call it inter. And everywhere that I was highlighting is now changing all at once. Okay? Now, this is probably a crazy thing to do if we're using as much as intersection. Or if I do it, I'm going to wind up having to change some stuff. So I'm just going to Control Z out of that, because I'm pretty sure that what I do might look a bit messy. But that Control D trick, where you're editing essentially multiple words that match your text, can be helpful too. Does that make sense? Okay, so I'm going to show you one thing that Visual Studio Code can't do. There may be a plugin that can do it, but we haven't, in the version we're using, we can't do this right now. But because Visual Studio Code is kind of a lightweight IDE, so it does lack a few things that some IDEs have. So I'm just opening the exact same code in NetBeans. Okay, so different IDE. So let's get rid of this. All right, so let's make that window smaller. Okay, so this load map, we've refactored it. It looks pretty good. But what you're going to find with load map is as you write it, you're going to load a bunch of different data structures. So if you start writing it like this, we put all the code in load map. Load map's going to get wrong. Okay? There'll be a bunch of loops to do this, then a bunch of loops to do something else, etc. And you're going to have things that are those. It's going to look a bit ugly. And it'll be hard to see the high-level structure and the fact that it's check all our APIs that they actually successfully look at that. So I'd like to basically make, well, the way to solve that is helper functions, right? I put in helper functions, load maps will look a lot better. So I can take this code, I can cut and paste it, and I can make a helper function. But in most IDEs, including NetBeans, but not including VS Code, unfortunately, I can basically take code that I'd like to make into a helper function. So this code would make a natural helper function, right? This is all about loading up intersection street segments. This code isn't, that's different. This return is returning the value that is okay, so that isn't, this is a logical helper function. So instead of me making that helper function by hand, I can right click, I can say refactor, and I can say introduce function. Okay, and I basically, it asks me, well, what would you like to call it? So let's call it load intersection street segments. I could choose to pass things into it if I wanted, but actually in this case, I don't need to pass anything into it, right? This actually should just load all the stuff, like load this whole thing. I don't need to pass anything to it. And it doesn't need to return anything. So I say refactor, and it's basically done, right? So it says load intersection street segments. It's all the code I had before, and there's load map calls it. Okay, so that was convenient. And I should always build, so I'm going to build this, and it says the build was successful, so that's good. And I can go down here, and well, I should go to the command line because usually I just do this from the command line. So we'll go up to where that was. Okay, so I'm going to run ece297 exercise 1, and I'm actually just going to run the proper tester this time. So basically, I want to run the tester that has the name, has func and enter in it. I don't even want to type the whole name. Okay, so ran, says 2 or 3 failed, while they wrote 1 function, so that's good. So it still works. So yeah, so that's convenient, right, for refactoring. But by the way, you can switch IDEs really easily, right? Like I know most people are using VS Code, but like IDE, well, VS Code literally is it's a lightweight IDE, so it's just like a super text editor. You just open it up in another IDE, you can edit your code, save it, and then open it back up in the other one, right? So you can go back and forth between IDEs. This one is good. NetBeans is better for actually making helper functions, but you can't figure out how to do it in Visual Studio Code. You just make helper functions in it, save the files, go back to VS Code, right? And IDE is not a really big deal to switch between. If you use CLion, CLion can also do this, right? So most full-featured IDEs have refactoring functions like this. And let's see. Okay, so that's it for refactoring. Let's take a break. You guys can have a chocolate bar for being good sports. And whenever you feel like it, we can start off again. Does that make sense? Okay, we're back. Not too much more. Okay, so other rules that you should follow in code style. Let me make sure this is going to get captured to Zoom properly. Okay, don't use magic numbers. You guys know what magic numbers mean? Ever heard that? Yeah, it's just use the number in code. Nobody knows why, right? Like, so let me give you an example of a little piece of code that does that. So this is a little function. It doesn't do anything super interesting, but it takes in like an array of the integers, and it basically goes through that array. And if it hits a number that is negative, it returns -1. If it finds a number that is 0, it returns 0, and otherwise it returns 1. Okay, so it's kind of checking whether negative numbers, positive, 0 numbers, or is everything positive. But reading this code, I would say it's not common, it's less bad, right? You should have a comment, but it's got a couple problems. It doesn't have magic numbers. So one magic number is 20. So turns out I wrote this code. I know that I'm going to pass in an array of size 20, but I actually use that number twice. Okay. Why is that bad? Well, the basic reason is I use it twice. What if someday I decide it needs to be 40? I might change one of the numbers, not the other, and that's a bug. If I use this number in 6 places, it's worse still. So, and if I do a search for 20 and I just change them all, well, that's not a very, it's kind of a bad thing to do, but also I might introduce a bug because there's another 20 that should be a 20, but I can't tell them apart. So we shouldn't do that. I shouldn't have used the magic number for the array size. We're also returning magic numbers. So we're returning -1, we're returning 0, and returning 1. It's not obvious what are these. Why do I return this or that? And again, there are comments, so sure, definitely have a comment saying, what am I doing here? But no matter what, these are not very easy to understand return values. If you run in a debugger and you look at this, it's going to be a bit hard to figure out what is this? Is this the right value or not? Okay, so you can avoid writing that code by using named constants. So, and there are multiple ways you can make named constants in C++. They all work fine, okay? I would probably tend to use the first two methods more, but all of these are okay. So the first one is I just declared a variable, and I said it's a constant. Okay, so constant is one weights. I'm using the convention here of all caps, right? That's one way people can tell that it's a constant. The other method I told you is to put a K in front of it. Those are both reasonable coding conventions. So everywhere where I see num weights, the compiler will actually just use 20. The code is just as efficient. The compiler doesn't care. But a person reading this, it's just easier to read num weights than 20. That tells you what it is. And remember that magic number. If I ever decide that 20 is not the right number anymore, I can change this to 40, and I'm confident that it worked everywhere. All right. So also my return value was weird, right? I was returning this -1, 0, and 1. Whatever comment is very hard to tell what the convention is. I can create a group of constants all at once with something called an enumerated type. So an enumerated type just means I'm going to give names to a few integers, like nicknames. So here I'm saying, I'm going to make an enumerated type called weight return. It has a constant has neg, which is equal to -1, has 0, which is equal to 0, and all pos, which is equal to 1. Okay, so get rid of this. And now what I can do is I can basically return those names. The code is the same, like the compiler sees the same thing. It just pastes it, and it sees has neg, it pastes it in the form. It's just as efficient, but they're now much more readable, okay? Because this name implies what it does. Has a negative, has a 0. The function that called this can also use the same constants down, so that code gets more readable. In the debugger, it can also show me these values, right? So that instead of seeing a negative form, I can actually see things like has neg, and that's easier for me to interpret. And then there's the last way to declare a constant. It's called a preprocessor constant. Compiling C++, basically it's something called the C preprocessor. Basically does text substitutions before anything else. So this defined basically says wherever I use the word weight 0, just replace it by 0 with the actual pattern. Okay. Also works fine. These two ways of making constants are probably a little more modern, so most people will use those, but all of these work. Does that make sense? The other nice thing is before I said that this check weights returned an integer, but actually there's only certain integers that should have been returned, right? The one I've got status codes here, names. I can actually change the return type and say it returns this enumerated type called weight return. And that gives a person reading the code a little more information. These are the only status codes that will ever be returned, and the compiler can actually do some extra type checking. So they can be converted to integers because they really are integers. So if you want to, the calling function could say cast this to an integer and start using it. But this gives you a bit better type checking and readability. All right, so let me go and do okay, so on the rubric for M1 and all the other ones you'll see, does the team have magic numbers? So just don't write magic numbers. Bad code, super easy to eliminate. Use any one of these 3 techniques and just don't do it, okay? Let me show you a quick demo on this. Okay, so is it big enough you guys can see us? Okay, I'm gonna get rid of these floating meeting controls again. This is the same program I just showed you, okay? And I've gotten rid of the magic numbers. I'm using my defined constants. And so that's that function. And I've got a main program now. So basically I've written by hand, essentially a unit test. So I basically create an array with 20 numbers in it, okay? From -1 and then 2, 3, whatever, up to 20. And then I print out what the return value of this check raise function is. And I just print it out as an integer, right? So this enumerated constants, given names to certain integers, but they really are just integers. So you do this, what do you think? If this sequence of numbers, this code, what should the output be? Should be -1, because the very first number is negative. So I should get, yeah, something is less than, it's not 0, but it is less than 0. So and the immediate returns has negative. So I should get -1, because has negative is -1, right? So if I wanted to, I could write a fancier print statement to say if it's -1, print has neg. I don't care. I just want to get -1. Okay, so I type make. All right, I want to rebuild it, so I'll say make clean to get rid of any code. Type make. Okay, it compiled it, and now I'm going to run it. So, okay, so, and it didn't output -1, it output 1. Okay, so go look at the code again really carefully. But you're right. When you read this code, that's what you would expect it to output. So, okay, we're now debugging again. So you're back in, I told you debugging is important, you're back debugging. Why is this wrong? Well, you need a minute to look at the code. There is a bug in it, okay? But it's hard to see. But I have another method to find it. So that's why I'm getting you guys to look at it. So I'll give you a minute to like look and see, then you figure out what's wrong with it. Whenever you give up, let me know. I'll show you a trick to find it faster.
See the function or in the thing.
It's in the function. So the function is broken, the test is correct. Okay, so no problem with this array within the following gets picked up, there's a problem in the function. So you're saying this state says it equals 0? You're right. So this is not an equal 0. Just test it at 0. This is an assignment make it 0. Okay? If you can actually do in the midst of this, it's weird, but you can do it. And this actually evaluates to be whatever, so it actually makes the change, and then it evaluates to be whatever the assignment was. Okay? So which was actually 0. So this will actually evaluate at 0 or false. But it basically is very hard to see this with eyes, right? The reason is your brain tends to fill it in. Like I did that this looks a lot like this many times. And still, and it's a bigger piece of code, especially it's harder to reading it, making the same mistake. Now you bring it up in the debugger and you'll skip over this line in a weird way, and now you go like, what is going on with this line? Right? And you probably find it. So that's why debuggers are good. But I'm going to show you the make file for this. There's something that can help you with errors like this. Okay, so in this make file, you don't need to understand all this, but basically this is just setting the flags we call G++, so we can pass flags to it. Right now, we're not passing very many flags at all, okay? I'm going to comment, in make files, the hash character is comment. Okay, so I've changed the warning flags. I have nothing for warning flags. I've changed this. Okay, so basically I was getting the default compiler behavior. The default compiler behavior when you don't ask for warnings. Tell me if there are errors, but don't tell me about dodgy looking code. If an error from the compiler is this code makes no sense. I cannot figure out the I cannot compile it. A warning is this code looks funny. I know what it means according to language standard. I can compile it, but it's an unusual practice to write code this way when I look at it. So what I've done here is I basically said pass to the compiler W all, that turns on essentially all warnings. Doesn't really mean all, it really means most. And then, well, actually, I guess it does turn on almost all warnings. And then I turn one off, okay, just because it's a while. So if I save this, Oops, let's see. Okay, so I'm gonna build this again. I gotta do make clean because it understands that the code is up to date, so I have to make clean to make it build. Okay, so now I get some additional output from the compiler that wasn't there before. And what is it telling me? It's basically saying on line 9, character 23, in this function, check weights, it's basically saying suggest parentheses around an assignment and use this truth value. Yes, that sounds a bit confusing, but it's basically saying this is fine. It actually shows me the line that it equals. And it says, then you want to put brackets around this because this is a bit odd. I actually don't want to put brackets around this. I actually want to go, what am I doing here? Right? This is not proper. So I should put the equals in. And if I do that, this will now work. Okay, so I can go down here. So the fix is really simple once I find it. It is just changing this to a proper equality operator. Okay. Okay, build that again. Okay, and now I get -1, which is what we expected before. So it now works. Okay, why am I showing this? Well, let me go back to the slides. Basically, the make file that we give you for this project, we turned on every reasonable one. There are a couple that are a bit in the lanes, they flag some code that is common and not problems, so those we don't turn on, everything else we turn on. That's actually good practice. Okay, it's not on by default. You should turn warnings on in the compiler whenever you do a project, but we already did it for you in this course. Okay, so what we turn on these warnings, we don't want you to have any warnings in your code. So we get a warning, fix it. Okay? They flag potentially problematic code. And you can look at it, and sometimes you go, this is fine. Right? I looked at the code and the warning is okay. So you could ignore it. The problem is if you do that, you leave a warning in, even if it's harmless, your teammates start getting like, okay, there's 10 warnings. Well, now there's 50 warnings. And then they add another routine with a 51st warning, and that warning is bad. It's telling you something you should fix right away, but they're not going to see it. Right? Once you get past, if you get past having, you have 0 warnings, you see immediately when a new warning comes in. When you have 100, you do not see the 101st. You just give up. So you lose an important tool that can help you find problems in your code. So, yeah, and all the projects I do for research, and then as an Altera, I set a policy of no warnings. Okay? We would actually fail the build. You can actually set a setting where if you get a warning, it basically says stop the compiler. So there's like teams that I'm not kidding. If you have a warning in the code, I'm just gonna break the code. So you want to stay at 0 warnings. There's an analogy people sometimes use of broken windows. There was a study done years ago that if you had a district where there were vacant houses and some of the windows were broken, people didn't fix them, but essentially it went downhill. Like as you see broken windows, it sort of makes you think it's kind of socially acceptable to vandalize things. If you fix them right away, then people it's not really acceptable. I won't do it. Same thing with litter, right? If you have a street or a park that doesn't have any litter in it, people don't take the litter. As soon as there is a bunch of litter, they start, it's very hard to say, you can say we'll have no litter. It's very hard to say we'll have no more than 50 pieces of litter per hectare, right? Like, because nobody pays attention to that. So warnings are like that too. You either have 0 warnings or you rapidly go to so many warnings, no more one to look at them. So we already done this. You tell the compiler to turn on W all useful warnings, and that's going to go on after that. And to convince you should do this, we are going to do some extra effort for the TAs, and they will lower your style marking and put warnings in to increase your learning. It actually and they won't miss it, because when you submit your code, part of the report that the TA gets actually includes how many warnings are in your code. Okay, TA doesn't even have to go look at it, right? So just get rid of them. Okay, another thing you should do is group related data in the classes. So you're going to have global variables, and you're going to tend to have a bunch of them in this class one. So you could make a different global variable for every single one of them. And this
the intervals, these domains are relatively restricted and long, with long public above it saying what these are. It's not terrible, but this is better. If I basically make a class, and this particular class, I'm not trying to hide any data, right? I'm just trying to group things together. So I can call it a struct as well. But basically, I'm making everything public, right? So I group together the information for it goes for every segment of public, and I basically made a vector of those. So now I've got one variable and so forth. So you could do that. You could also make one struct that has 4 vectors in it. That's fine too. But basically grouping away the variables together this way. So we did that for the string segment data, put it in the struct rather than giving you a whole bunch of different data. The place where you can do this is the local state. It's like kind of trying out the inside some kind of struct. It's not really useful to put accessors around it because you're using it to make an API fast. So the API already is the interface. Adding another interface behind the interface doesn't really make any sense. Okay? But grouping the data together does.
Does that make sense? Okay, defensive coding. So you're on the milestone 1 rubric, you'll see that you don't have to do this. It's considered an additional bonus. Okay, so you won't lose any marks for not doing this, but if you do it, the TA is told to take into consideration for like a little bit of extra marks. So basically canceling out some other mistakes. Okay, so what is defensive coding? Defensive coding means I'm going to write some checking right in my code. So unit tests where I have code that will check my functions. Defensive coding is right in my functions that doing some self-checking. So the most important of these techniques is something called assertions. Have you ever heard of assertions? What they are? Okay, so assertions are you're verifying assumptions in your code. You're verifying it at runtime. To do this in C++, you include this header file, assert.h, and that brings in basically a function called assert. Okay, which is helpful. Okay, so here's my fine street signals intersection function that we've kind of written down many times. And the code we had before let's not look at this assert. Oops, what's going on here? Okay, I can't draw on this right now. Okay, there we go. Okay, so if we don't look at this assert, we just look at this instead. That's the code we had before. We just returned our saved vector of street segments for that intersection. Now, what if somebody passes in an intersection of that is zero? It's less than 0, or it's more than the intersections of the city. You don't have to handle this case. Okay, we told you the milestone 1 header says we will not call you invalid IDs, so we will not test this case. But you're later going to build on your own functions some additional stuff in milestone 2, so you might go, well, I want to check it, right? Because if I ever have my teammates calling this in the wrong way, I want to kill it. Because then I can find the bug faster, right? When things are going wrong, it's better to basically see the failure right away. We don't backtrack so much. So I put in this assertion. The assertion says verify the intersection ID. Basically, as long as this is true, okay, the assertion does nothing. If this ever becomes false, the assertion will kill your program with an error message. So if intersection ID is greater than or equal to 0 and it's less than the number of, or the size of this vector that we've preloaded, then it will go down and do this. If it ever fails this test, we're about to have an invalid memory access because something has gone wrong. Either our load map is broken or we pass in bad ID. In that case, the assertion actually will kill the program and it'll print out this message. So basically, I'm doing some unit tests. So it tells me the name of the program that's tested with street map, tells me that the file is m1.cpp, it's log 56, and I'm in this function, find two segments of intersection, and there's an assertion, and it tells me what the insertion is, and it fails. So it tells me exactly this program, this line, this function, you failed this assertion. So now you know something's gone wrong, you can bring it up and you can inspect the code, or more likely you bring it up and figure out what went wrong. If I didn't have this insertion, I would have corrupted memory. It would have taken a long time for the program to go crazy and be a lot harder to catch. So the assertion was useful. It's better than a comment. So I could put a comment saying, make sure this is in range and make sure this is preloaded. The assertion is stronger
then a comment that actually checks it. Does that make sense? It actually tells everybody reading this routine, I expect this to be true, and I will check it, okay?
Okay, so that's useful. Now, in this course,
First, for speed testing, that assertion doesn't take much time, but it does take a little bit of time. So you might go, well, what if that's gonna make it a bit harder for you to pass performance tests? Maybe I don't want it, but it's speed test in my program. Also, while you're doing your own runs and tests, you want to have these assertions that kill your program. Once you submit, you might go, I don't get to fix it anymore. So just keep going, right? I don't even care if things look dodgy, just keep going, don't crash. And that's probably reasonable, because we're testing your program, and it turns out that by luck, you don't crash, it doesn't cause that many failed tests, like okay. These are not uncommon. So you can turn off all assertions by defining a symbol called ladybug. So you put that above where you put insert that H, and it basically turns off the check. So what you can do is before you submit, if you put assertions in your code, some header file that you include in all of your files, and internal.h, or maybe you only got one CPP file. In that case, if you've got one CPP file, you put this at the top of it. If you've got multiple CPP files, you just had a header file that all turns all your assertion checking off. You do that, you compile, you test one more time, because you always test the code before you submit it. Well, we run tests anyway, so I guess even if you don't do it, we will run the test for you. But this gets rid of any speed penalty, and it means that, okay, I'm going to let it slide for the testing that we do. Does that make sense?
Okay.
Asserts are an important defensive coding technique, probably the most important. Another one that's useful to do is if you delete a pointer. Okay, so I had some memory allocated with new, I got a pointer to it. A common programming bug is that you use the pointer again, even though it no longer points at anything useful. And this is another kind of memory corruption, and it's hard to find. It's still pointing at the memory you deleted. If nobody else has reused it, it'll actually still work. But suddenly, if somebody else reuses it before you try to do it, you'll crash. So it can be hard to find. If you just do this right after deleting a pointer, you set it to null. It means that if you ever try to use that pointer again, if you ever try to use it to try to dereference it, try to access part of the structure that the pointer is pointing to, that will immediately say false. So if I didn't do this, this line will probably not seg fault. Like it will, but it's done something bad, right? Like it is a bug. You might have worked with somebody else's data. It might work today, but then they add some more allocations and it stops working tomorrow. Guaranteed this will give you a seg fault instead of a null pointer, because that's always an illegal value to access. And then the last technique that you can use, that I use in a lot of my more complicated programs, is to actually write validators for your data structures. So the street map that you're working with is a graph. You could actually write a validator that checks that the graph makes sense. If an intersection says it's connected to these street segments say they're connected to that intersection. Okay, so you can call the various functions different ways and make sure that they kind of agree, right? And you're running additional functions, you can make sure they agree with each other. So you can, and this is a very useful technique. So Quartus, for example, has strong internal error checking. So it has complicated data structures that are setting up graphs, things called hypergraphs, and so on, describe the circuit, the chip. And as we run these complicated algorithms to figure out how to map the circuit onto the chip, when we're done, any of those algorithms, a completely separate checker is called that basically goes through the data structures and validates all the things that we know should be true. So, for example, there's a placement algorithm in place. It chooses where to put every one of, say, the million things in your design. It will check every single thing in your design has been assigned a location. It will check that location is compatible with that thing. If it's a register, it got put in a slot, it will be a register. If it's a RAM, it got put in a slot, it will be a RAM. It will check that two things are never put on top of each other. It will check that never put outside the chip. It checks all sorts of stuff. Those checkers are very useful because you write the checker and it just always checks the data structure. So this is not turned off. It's even the machines you're running at 241, these checkers are on. If they ever fail, they kill the program. And that's because for a program like Quartus, where it's generating hardware designs, it's actually forced to continue if you have a potentially corrupt state that is to destroy the program. the program, the person's unhappy, right? But they either restart it or they contact you, it's better than they get a bad system. And these verifiers cannot be turned off actually, right? And that's by design, I basically made them to not be turned off. They run on every single compile in Fortis, and I do this in other programs already too. A program like Fortis, the optimization code is complicated, changing it all the time, trying to get better results. The verifiers are simpler. They verify and they don't change as often. So they are quite good at catching if you made a mistake in the optimizers.
Okay, we don't expect you to do either of these two things. Well, this one is probably do, right? Probably should have many folders in this list anyway. The code using SQL, but you just use some better coding practice. You probably won't write a self-checker, but it's a good technique to be aware of. If you do use asserts, or go all the way write a checker, show it to your TA, because as I said, it's on the rubric as not expected, but basically it's like an extra, it'll cancel out some other mistakes, right? Your TA will be extra happy with that. Does that make sense? This is something I found on the internet. There's a program that would basically, you type into a web page what the text you would like on a cake, and it automatically controls the machine that prints it on the cake. And it appears to not understand certain German accent characters. So somebody tried to make a cake for their Aunt Elsa, and they got confused about some of the characters and they started printing a bunch of HTML error messages on the cake. This is probably a very confused Aunt Elsa as to what is this cake celebrating and what do these errors mean. And this is an example where, again, they probably should have had a validity checker that would actually kill the program rather than just kind of let it sneak through and go for it and print this bad cake. Okay, so I'm gonna do a quick demo of that. And that is the last demo, then I'll just sum up. Okay, so let me go back to, where have I got this? VS Code is there. Okay, so I'm gonna put an assert in here. So I told you the first thing I wanna do is I have to include the standard library file, assert.h. When you wanna get something from the standard library, you use angle brackets. Okay, it just changes where it looks for the files. When you wanna get a header file from your own program, you use quotes. Okay, so I put in assert.h, and now I'm gonna write the assertion. So assertion is right here. Okay, so assert, and it's just a function. So I say assert, and I think I called it intersection. Oh, that's IntelliSense taking a long time again. Okay, I called it intersection ID. Okay, so intersection ID should be greater than or equal to 0. And because I'm using it to look something up in the vector. Okay, so it can be, and it should be intersection ID should be less than intersection street segments dot size. Okay, that's the end. Okay, so that's going to kill my program, but that's not true. Okay, so I hit Control S to save that. I build. It built fine. Now I'm going to run my test. Let's get rid of this test. All right. So let's just run ece297 exercise 1 again. I'll go into more because I just want to see what happens for the first test. Okay, so the first error I get is in directly connected. That's one of the functions I haven't written yet. And if I keep going for a while, the whole first test ran, and 2 out of 3 tests failed, which is the same as before. Okay, so the cert didn't do anything, which is good. Okay, so never got called with bad IDs. So I'm going to go back out here. Okay, so I want to bring in the unit tests. The reason I want to bring in the unit test that I was just running is I'm actually going to add, I'm going to put an invalid ID in it. Okay, so I'm going to make it call for invalid ID and to see what happens. Okay, so do you guys remember how to get the unit tests? memory testing thing. How do I get the unit tests? I want to bring them into my project and actually do that. What's that? They're going to go in the test directory. ece297 exercise is my friend again, right? So if I don't remember, I can type ece297 exercise -h, right? And I notice there's this debug tester. So now I'm going to say ece297 exercise milestone 1 -- debug tester. And I don't remember the exact name of the test, but I do know it has func and functionality intersection in it. So I'm going to do that. Okay, and that worked. It basically says it copied over the test files. So now if I go back to Visual Studio Code, I should be able to go into my file explorer, go into tests, and under tests, I should see it. And I do, right? So remember last week, there's basically a test driver that just runs all the tests. We don't care about that. There's a helper function file with utilities. I don't care about that. All I care about are, is this file that actually has the tests I want. Okay, it's got a bunch of setup. Then it has the tests for the routine I want, find street segments of intersections. There's a whole test suite for that. I'm going to go past all those because I want to keep those. But I'm tired of seeing these other failures, so I'm going to get rid of them. Okay, so there's other two functions I haven't written. I'm going to delete all the tests for them. Okay, and Control S to save. I'm going to build this. So I click on my Makefile tools, build it, and then I'm going to run it. And it should all work, right? Because all I did was copy over the tests. So I run this, and this is the super confusing VS Code thing. Expected that, but was that? Okay, actually says I broke my test. Interesting. Why would it be that? So this is saying I somehow managed to break my code. So maybe I have broken my code. Let's get rid of this. All right, let's try this again. All right, let's make sure this is built. Okay, and let's run this. And expect, I wonder if I deleted something too much here. Let's see. I don't think I have. So, oh, it did pass. Oh, yeah, this is Visual Studio. Oh, not use Visual Studio terminals. I keep looking at old output whenever I do it. I used to command terminals to do that. Okay, so it passed. Thank you. Thank you for noticing the new output. So let me hide these floating mean. Okay, so I expected that, right? Because and now I don't have all this other garbage. Just got the one test. But now I'm going to go in here, and I'm going to actually insert a test where I give it a bad value. So let me make one new test. Okay, so I'm going to say the expected is the vector of street segments that I expect. I don't care, we'll say it's those. But let's pass in -1. Okay, so you agree that's an invalid intersection. So I'm going to compile that. I'm going to run it, and we'll see what happens. And we get an assertion. So it's exactly what I told you. It basically says line 62 of m1.cpp, we failed that insertion. So it immediately caught it, which can be very helpful to us. And it was let's go look at line 62. So we can go back to that line and see where we are. So right there, okay, exactly what we expect. So now I know I should go debug this. Now I told you, okay, maybe I want a little bit extra speed, so I want to turn that back off before I submit. And also, once I submit, I'm just going for it. If there's anything wrong, just keep trying, and maybe I'll get lucky and the program will complete anyway. So I don't have to go delete my asserts. I can just do that and define and debug. So define no debugging, which only affects assert.h. If you ever look inside assert.h, you'll see it looks for this, and if so, it turns itself off. So I'm going to save. I'm going to Whoops, go back to the makefile tools, build this again. Okay, so now I'm going to run it, and this assert won't fire. Okay, and I did get an unhandled exception. Okay, so I do actually have a bug in my program. The assertion didn't file. It basically just says your program crashed. So I did in fact corrupt memory. I did manage to crash the program. It actually crashed using the close. It crashed on the test that corrupted memory, so that's good. At least it crashed right away. But this isn't as helpful as an assertion. And if I actually change this, let me just try one other thing. So let's change this from -1 to, well, I guess I won't bother doing that. Basically, if I change this to another legal value, it might not actually crash for quite a while. Okay, it's kind of random. Is it going to get corrupted so badly that we crash right away? So the assertion is better. Okay, but I was able to easily turn it off because now I don't want it when I submit. And that is it for what we're going to talk about today. Let me quickly hit the last couple slides. Just a summary of this. Yeah, so I guess we talked about this at the start. Code's written once, but it's read many times. So you can modify it. You want to keep your test with the code. That's why we have unit tests, and you want to keep your documentation with the code. So you put the comments in there. I mentioned this earlier. So if you want to get better at writing good codes, good style in the code, do code reviews. Okay? And Google, I think, does this in a very disciplined way. But you literally should not get code into the source control system until you go through code review for the subsystem you're in that matches the overall functionality, and a review for the style of the code being good. Until you do that, no one else can see the code. It doesn't really go in the source control system. And you can look at this rubric, which basically summarizes how we're marking you on this, which is basically what I just said in this presentation. If you want to learn more, there are books on how to write clean code, and you want to buy a book, you can basically go look at Google Style Guide, which is big. It's more than, style guides can get kind of long if companies want to be really prescriptive. So if you're curious, you can go look at this and see what does Google think about all sorts of C++ constructs. But you can see it's kind of long. It's like a whole bunch of hyperlinks. We don't expect you to follow all these complicated rules. We just want the most fundamental things, which are short functions, no duplicate code, good variable names, no magic numbers, etc. And those are the core of writing good style. Okay, that's it for today. Thanks, everybody.